Welcome to doassignment-ca. Here is the problem. A particle moves along a straight line with an initial velocity of 6 meters per second. It is subjected to a deceleration equal to negative 1.5 times the square root of v in meters per second squared, where v is in meters per second. Determine, Part A, how far the particle travels before it stops, and Part B, how much time this takes. Now let us work through the solution step by step. We are given a particle with initial velocity 6 meters per second, subject to a deceleration equal to negative 1.5 times the square root of v. Since the acceleration depends on velocity, we will use two forms of the kinematic equation, one to find distance and one to find time. Using the relation a equals v times dv ds, we substitute the acceleration and divide both sides by the square root of v. This separates variables into v to the 1/2 dv on the left and negative 1.5 ds on the right. We then set up definite integrals with v going from 6 to 0 and position going from 0 to s. Evaluating the left integral, we get 2/3 times v to the 3/2 evaluated from 6 to 0. At v equals 0, the term vanishes, and at v equals 6, we get 2/3 times 6 raised to the 3/2, which equals approximately 9.798. Setting this equal to negative 1.5 times s, we solve to get s equals 6.53 meters. Now for the time, we use a equals dv dt. Substituting the acceleration and separating variables gives v to the negative 1/2 dv equals negative 1.5 dt. We integrate the left side from v equals 6 to 0, and the right side from t equals 0 to t. Evaluating the left integral gives 2 times the square root of v from 6 to 0. At v equals 0, the term is 0, and at v equals 6, we get 2 times the square root of 6, which is approximately 4.899. Setting this equal to negative 1.5 t and solving gives t equals 3.27 seconds. To summarize, the particle travels 6.53 meters before stopping, and this takes 3.27 seconds. As a quick check, the ratio of distance to time is about 2 meters per second, which is a reasonable average velocity for a particle decelerating from 6 to 0. The integrals also converge properly as v approaches 0, confirming the solution is mathematically sound. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.